All right, you guys, so 142 says use a calculator to graph this function, so I already put that in there. 12x divided by x squared plus 4. Make sure the denominator is in parentheses when you graph it. Looks like this. Is it even, odd, or neither? Well, if you go to the table, you can see that if I put a negative 3 in, I get negative 2.769. If I put a positive 3 in, I get positive 2.7692. If I put a negative 2 in, I get negative 3. If I put a positive 2 in, I get positive 3. What that means is it is odd. Okay. If you look at the graph, you can also see that if you flip the x and the, oh, sorry, that's the inverse. You can also see that if you folded it twice, once around the x and once around the y, it would match up, which means it is reflective over the origin. If you folded it twice, it would match up. All right, additionally, determine where the function is increasing, decreasing, a maximum, a minimum, concave up, concave down. Okay, so let's look back at our picture. Oh, please come back up. What happened to my calculator? Well, it looked something, if memory serves, it looked something like this. Oops. Where it kind of went up here and kind of went down here. It didn't look like there was actually a minimum or a maximum or really concave up or concave down. It's continually increasing. It's getting bigger. I think it'll get bigger forever. And it's not decreasing at all, right? It's always getting bigger. Huh. Oh, there it is. Oh, wait, no, look. Looks like it did increase here, and then it was decreasing. So where was that? 2, it was higher if we look at the table. At 2, it was 3, yeah, and at 3, it was 2.769. And then forever, is it going to get smaller? Looks like it'll probably level off somewhere, maybe. So it was increasing and then decreasing. So I did not draw that from memory correctly. It was kind of like this, and then kind of like this. So here also we have concave up, and here we have concave down. Did we hit all of those? Maximum. This looks like it's a maximum right here. It looks like you have a minimum right here. 3. Was it maximum 3, minimum negative 3? If memory serves from the table. All right. Write an equation for the inverse of each. Okay, switch the x and the y and then solve. You guys can probably skip this because I bet you did this on your own because I know you do it. We flip or switch the x and the y, so we have x equals y minus 3 cubed plus 2, so add 2 to both sides. X plus 2 equals y minus 3 cubed. And then to get rid of that cube, I like to take both sides to the 1/3 power because it'll cancel that out. And sometimes that's just a little bit easier to figure out. So x plus 2 to the 1/3 power equals y minus 3. So y equals x plus 2 to the 1/3 power plus 3. And y is really f. Here, I'll just erase this. Y is really the f inverse of x. Okay? And for the second one, when you have a rational function, things get a little funky as always. But we switch, so we have x equals 2y minus 1. It's hard to separate out the y when you have a y in the numerator and a y in the denominator, but I'm going to cross multiply. So on this side, I'm going to have x times y minus 1 equals, and then this side is just 2y minus 1. I'm going to distribute my x minus x equals 2y minus 1. Now I want everything with a y on one side and everything else on the other, so I'm going to subtract 2 y's from both sides, And I'm going to add x's to both sides. I'm going to do that at the same time. So now I have xy minus 2y, and that's where I can take that y out. I can factor that y out, is equal to x minus 1 or negative 1 plus x, whichever way you want to write that. Factor out my y, I have x minus 2 equals negative 1 plus x. Divide both sides by x minus 2. And you get y, although, like I said, I should be writing that f inverse of x or g inverse of x. G inverse of x is equal to negative 1 plus x over x minus 2. All right, what is this? Some sort of graph. And remember, most of this test is going to be multiple choice, you guys. Use the graph to the right. I guess it's below. State the intervals where the function is increasing, decreasing, concave up, concave down, as well as the locations of any maxima or minima. All right, so here we have concave up, and I would say that's from about the point of inflection. It looks like it's about negative. Well, here as we go, concave up, concave down. Okay, there's a little point of inflection there, like a bell curve. And so I would say that is from the concave up is from x is greater than or equal to negative 5 to less than or equal to, what is this, 1, right? From here to here. Concave down, x is greater than or equal to 1 and less than or equal to, let's say, what is this? 1, 2, 3, 4, 5, 6, 7, 8, approximately in this picture. We have a maximum right here at, what would y be? 1, 2, 3, 4, comma 4, maximum. And it looks like we have a minimum at negative 2, negative 4. Looks like, let's do yellow. It is decreasing from negative infinity to negative 2. It is increasing from negative 2 to positive 4. And look at that. That was, it is increasing from negative 2 to positive 4, from my lowest point to my highest point. And then it's decreasing again from 4 to negative infinity. So coming out here, we have negative infinity, and this way it is, oops, this is positive infinity, duh, and over here is negative infinity. Okay. Use a graphing calculator to graph this. Where's the function? Okay, I'm not going to do any more of these. You guys can do this. You guys can do those. Yeah, that's all the same stuff that we've already done. So do that for extra practice, but don't, you know, go neurotic about it. Let's see, what else we got? Okay, write an equation for the graph below in terms of what? In terms of what? Sine and cosine. Okay. That's easy enough. All right, so you know what? Let's just graph. What does a normal sine curve look like? Let's start with the sine. What does a normal sine curve look like? We do sine of x. Make sure you're in radian mode. I already checked. And we'll graph. All right, so a normal sine starts in the middle. And it looks like this one starts at the bottom. So actually, why don't we do this as a cosine first? And we'll go back. We'll make it cosine of x. What does that look like? Cool. Cosine of x starts at the very top. So if we go back and we change that to be negative cosine, it'll flip it over. Okay, so now we're starting at the bottom. And let's stretch it. Okay, a normal cosine curve goes down to -1 and it goes up to +1. So its amplitude is 1. It's 1 away from the middle. But here our middle is 2 and it goes up 2 and down 2. So we're stretching it by 2. So we're going to go back. We're going to change our amplitude. Instead of negative cosine, we're going to say -2 cosine. Let's see what that does. Cool. So then all we have to do is, it doesn't start at -2, right? It starts at 0, so we've got to add 2 at the end. So let's see if we can do that. +2. There we go. And I think all of these, you guys, on your test are multiple choice. So you'll be able to look at the graphs and make those decisions for yourself. So it looks like this is the one for the cosine. So what did we do? We had -2 cosine of x plus 2. Now let's do the sine. So let's go back and graph the sine. Clear. And we're just going to graph the sine of x. So as you can see, we need to shift it to the right because it starts right in the middle, but we want to start right here at the bottom. So we're going to need to shift it to the right, which means we're going to subtract. And if memory serves pi over 2, if we shift it pi over 2 to the right, that should do it. Let's check. Pi divided by 2. Okay, let's see. 1/4 of a circle. Yeah, we just switch it 1/4 of a circle. Now it starts there. Now we need to stretch it. We're going to stretch it by the same amount, right? So second insert, we'll put 2. Cool. And now it's the same thing. We just need to shift it up at the very end by 2. Cool, and let's trace it and make sure. If we trace, it starts here at 0, 0, which is where it starts, and its highest point at pi, right, which is 3.14, looks like it is up at 3.99, so 4, yep. I wonder if we can find a maximum right there. And if that'll give us a perfect answer. Yep, 3.1415916 looks like pi, and y equals 4. So we're good. And that was, we had 2 sine, we stretched it the same, but here we shifted it left and right instead of flipping it over like we did the cosine, minus pi over 4. But we had to move it up 2 also. Ooh, almost running out of time on this video. Graph at least 2 cycles of each of the following trigonometric functions. You guys just put this in your calculator, okay? It's no big deal, just put this in your calculator. Oh, I thought we were done. Systems of equations. Okay, one more video.